Okay, so yeah, let's begin. So welcome everyone to another installment as part of the KL Mini Hackathon. Today we have a back-to-back session. Firstly by WeiHan, which will be presenting talking about abstraction simplified, followed by introduction to Startnet by John. So WeiHan, if you're ready, feel free to start. Oh, just a quick introduction. So WeiHan is, if you missed the previous session, he's a currently working as a document engineer. He's a founding member of the KL, KL as well. So
Okay, thanks, Kevin. Let me just share my screen very quickly. All right, can you see my screen? Just to double check. Can see?
Yep, that's good.
All right, cool. Yeah, so let's start right away. So just to reintroduce myself. Hi, my name is WeiHan. So like what Kevin said, I'm working as a blockchain engineer at a company called notorious. So yeah, basically do a lot of L1 stuff. So yeah, today's session is going to be on account abstraction, like what it says here. But I won't go too deep into the technical parts because it will take a long time to talk about technical parts. But I believe this is more like a simplified version of account abstraction, or I would say AA. And hopefully it will give you an introduction to account abstraction and where you can start your research on. Right. So what I'm going to talk about today is on 4 parts. Firstly, introduction. Secondly, use cases. Third, the evolution, and lastly, the state of adoption currently, right? So let me just open the chat. All right. So yeah, without further ado, let's start with some recap, right? So just to refresh your knowledge on before we really go into account abstraction. So for those who have attended the first session on Ethereum basics, you will see something like this. If you haven't attended, it's fine as well. But basically, what this slide is trying to say is that Ethereum is just a chain of state facilitated by a chain of blocks. So that means that Ethereum is nothing more than just a transition of world state from one to another, right? And how can a world state transition to another? The second world state is that is facilitated or is executed by transactions, right? And transactions are included into a block, right? So this is the Ethereum basics. And inside the world state, right, the primary citizen in this world is an account or many accounts, right? And in this one account, or an account is just a mapping of address to account state. And account state contains non-balanced storage hash and code hash. Okay, this is just a recap. So now we're going to talk about more about accounts, which is firstly the types of accounts on Ethereum, right? There are 2 types of account in Ethereum. First one is called EOA, externally owned account, right? So what is an EOA? It's very simple. So in an EOA, basically, if you have a combination of these 3 things, signer, EOA, and funds, signer means your private key, you will be able to perform a transaction, right? So EOA basically contains a public address and can store user funds. User funds means your ETH, right? And the transaction can be initiated if a user or an external actor sign the transaction by creating a signature using the private key with the EOA's public address, right? So this is how an EOA can transact. Secondly, we have an account called contract account, right? So again, we have these 3 things: signer, EOA, and funds. With a combination of these 3 things, you can make a transaction such that you can activate a contract account which might hold some fund, right? And then this particular contract account can transact, or to be more precise, is to perform message calls, right? And the key thing here for contract account is that it cannot initiate transactions. It must be activated by an EOA, right? So everything that you do in Ethereum, you must always start with an EOA, right? So to simplify things, EOAs are called the first-class citizen in the Ethereum ecosystem. No matter what you do, you need to start with an EOA, right? And we'll explore why is this bad, or why could this be bad, right, in terms of EOA. So the first problem with, or the general problem with EOA is that there's no separation of concepts. So what do you mean by concepts here? So there are 2 concepts that we are trying to, that we have, right? So the first concept is a concept of signer, right? A signer means like your bank password, right? The primary responsibility for a signer is to allow people to spend tokens, right? Wait, I'm looking at a lot of, sorry, unanimated people. So can I just admit all? Yeah, I'll just admit all. Okay, sorry for the interruption. But let me just proceed. Yeah, like what I said, the concept of signer is to allow people to spend tokens, and you have another concept which is accounts, or EOA in this case, which the primary responsibility is to allow people to hold tokens or to hold money, right? So if you think about it in terms of Web2 concept, you have your bank password, which the primary responsibility for a bank password is to access an account. And the primary you have another component, which is your bank account, and the primary responsibility for a bank account is to make transaction, right? So to make transaction and also to hold money. But in the concept of Ethereum in the concept of EOA, the current EOA system, is that these two concepts of signer and account, they are merged together. So what do you mean merged together? It means that you can't have one without another, right? So in order to make a transaction, you must have these three things, or you must have these two things, which is signer and an account, or EOA. So let's explore just a quick scenario, right? So let's say you yourself as a user, you have your own private key, or you as a signer, right? You hold your own private key, or you hold your own seed phrase. If you have your private key, that means that you have access to your EOA, in which you would have access to your funds. So that means that you have your funds, right? And what if you lost your private key due to whatever reason, right? You write on the paper, but then you lost it. So if you lose your private key, if you lose your seed phrase, you will lose your money forever, because you will have no access to your EOAs forever, right? There's no way to recover it. And the third scenario will be someone has your private key. So if someone has your private key, they will have your own account. They will have your whole account, and they can transact with your account, or they can just steal your money, right? So as simple as that, right? So there's no way for you to decouple your private key from your account. So hence the general problem with EOA right now is that it's a single point of failure in the current EOA system, right? So that's the problem that we are trying to solve with account abstraction. So now this is the account abstraction part. So what exactly is account abstraction, or what's the purpose of account abstraction? It's just very simple. It's trying to combine the concept of EOA and the concept of, the concept of EOA and also the concept of contract account, so that a single contract account can both transact with your tokens and create contracts. So that means that they can initiate transactions on their own, right? So this is the new type of contract account. And the primary purpose of account abstraction is also to decouple signer with account. So decouple here means that it's trying to separate the concept of signer with the concept of an account, right? So in this diagram here, it may look very subtle, but if you look closely, this signer is no longer merged with the account and funds. The concept of signer here, or the primary purpose of the signer, is to allow a user to access an account which holds some funds. And this account here is a smart contract account. And once you have access to a contract account, you would be able to perform a transaction, right? So from this diagram, it doesn't look like, oh, it's account abstraction, but this is literally account abstraction. It's just decoupling the key from the account. Okay, so now that hopefully you understand what is account abstraction, let's talk about the use cases, which is the fun part. Generally, there are four major categories of use cases: account recovery, signature abstraction, gas abstraction, and batch operations. But to be honest, with account abstraction, you can unlock a lot of different things. So it's really up to your imagination on what kind of application can you build with account abstraction, because it's really, really wide. But let's explore some of the major ones, I believe. So the first one is called account recovery. So very simple, right? Previously, I mentioned, right? So if you lose your private key, you lose an account forever. So the concept of account recovery is that, okay, even if you lose your current signer or your current private key, let's say, you would be able to set up a backup key such that this backup key can still access your smart contract account. So there's no longer the concept of if you lose your private key, you lose your account forever, because there could be many backup keys. So yeah, it really depends on how you set up this particular wallet, or this particular key, or this particular backup key. Yeah. So that's the first major use case. And the second major use case is signature abstraction. So signature abstraction, basically, is to allow two things: multi-sig or multi-signature enabled, and secondly is you can have different signature schemes. So let's say if you don't want to go with the default signature scheme that Ethereum has, you can go with like BLS, Quantum Safe, or whatever other signature schemes that you have. But in this example, let's say you have a wife which has her own private key, and you also have a husband with in which he also owns a private key. With the combination of these two keys, you can access a joint account, right? So this is how we can have a multi-sig application enabled. So yeah, this is one of our example. There could be many other multi-sig examples. And third, we have the gas abstraction use case. So gas abstraction, basically, the first, I think, primary use case is gas sponsorship by paymaster. So the idea of this gas sponsorship is that this paymaster can sponsor the user gas fee. So why do we want to sponsor people gas fee? Is that we will want to onboard more users into the entire ecosystem. So that means that people from Web2, even if they create an account, right, a new MetaMask wallet, let's say, they can interact with the blockchain or with Ethereum without paying ETH, right? Because the gas fee is sponsored by someone else. So an example, right? You have a user with a private key, and then this user can access the account with the private key. And with the account, he or she can interact with the decentralized application without paying any gas fee, because the gas fee is paid by the paymaster, right? So if I give you a real life example, let's say I'm Binance, right? If I want to onboard more users from Web2 to Web3, if they create an account on Binance, let's say I will allow Binance will sponsor them free gas fee for 30 days because they are new users. So that's one of the use cases that I can think of when it comes to this gas sponsorship. It would dramatically improve the user adoption when it comes to adopting people to a new platform. Yeah, let's say. And lastly, we have batch operations. So batch operation is just batching transactions into a single transaction. Guess it exists in UA as well. Yeah. But in this case, this is also one of the use cases for account abstraction. Yeah. Coming back to batch operations. So you have a user that can access an account, and this account can do multi-calls, basically calling like multiple contracts at the same time. So let's say if I were to give an example of like let's say you are playing a game, right? The current system is that you have to keep, every time you make an action, you have to keep making like MetaMask transaction, or you have to keep signing the transaction. So it's not smooth for user experience. So if you have an application that can enable the account to perform multiple calls at the same time, so it's just a better user experience for users as well. So yeah, these are some of the use cases for account abstraction, and definitely, like what I said, you can explore more, definitely more than this, right, in terms of account abstraction. All right, so let's explore the history of account abstraction so that we know like where we stand right now. So account abstraction, the concept of account abstraction, it started in 2017, right? Actually, it started in 2016 when Vitalik, I think he published an article on account abstraction in 2016, but I think the first EIP is published in 2017, which is EIP 86, right? So you can see these three EIPs here. They are all stagnant. Only the last one is draft. So I'll focus more on the last one later on, but let me just go through the previous EIPs as well. So in EIP 86, just to summarize briefly, what it's trying to do is to abstract signature verification and non-scheme. And users can create like non-hard-coded contract accounts. So as compared to the use cases that I mentioned just now, it doesn't support all of the use cases, right? Like gas abstraction, multi-calls, multi-sig, I believe, it also doesn't support. So it's still very limited. Even though it's still very limited, it still requires a protocol level changes. Protocol level changes could potentially means that a hard fork. And we know that protocol level changes require a lot of effort, both from the developer point of view and also the user point of view. So yeah, it's not worth it to use so much effort for this minor change, right? And lastly, it still doesn't remove EOAs, right? the concept of removing EOAs is that in the long term, we would want to transition from a state where EOAs are the first class citizen to completely no EOAs at all, meaning it's being replaced by smart contract accounts. I think in the long term, that's what the Ethereum Foundation is trying to do, but I don't think it will happen in upcoming future. Yeah. Next, we have EIP 2938. So in EIP 2938 introduces two new opcodes and a new type of transaction. I won't go too deep, but basically it allows smart contracts to act as EOAs to transact and pay gas fee, right? So this EIP is more like a restricted version of account abstraction. It still doesn't support all of the use cases that I mentioned just now, and it requires protocol level changes, which is not efficient, right? And not impactful enough. And lastly, the second last one, which is EIP 3074. This is an interesting one. So let me just use a diagram to illustrate. So in EIP 3074, it has, I believe, two new opcodes. So the first opcode that it introduces is an opcode called auth, which basically means authorization. So user can sign a message with this new opcode called auth, right? So with this signed message, right, it can invoke a smart contract to to transact on behalf of user, right? And this smart contract can make transactions on behalf of user by using an opcode called auth-call, right? So smart contracts can use auth-call to perform transactions. So coming back to the previous slide, the major changes are, like what I said, it's sort of like the opposite of the previous one. Now, the EOAs can act as a smart contract, or the control of EOAs is delegated to a target smart contract. So with this change, you enable some of the use case that I mentioned, which is gas sponsorship and multi-core execution. But the huge problem that is being that this EIP face is security issue. So imagine what if your user accidentally signed a message with a malicious smart contract, right? That particular smart contract can wipe out the user funds very quickly. And we know that from history, humans are very bad at managing malicious things, right? So it's still not a good user experience, right? And users are still expected to back up their seed phrase, which basically still doesn't eliminate the idea of single point of failure, right? So yeah, these are the three EIPs that are stagnant, the previous ideas. And now let's go into the current EIP, which is the famous one, EIP 4337, right? So I won't go too deep into the technical details, but I'll just illustrate the flow of how this EIP works in terms of the infrastructure layer or infrastructure level, right? So first step is that a user will send something called a user operation into a separate mempool called user operation mempool. So this user operation mempool is an alternative mempool than the current one that we have right now. So it's like the second one, right? So this user operation, you can think of it as a replacement for a transaction, or not really a replacement, maybe a secondary type of transaction, or you can think of it as a new type of transaction. It's basically like a JSON object, sorry. Yeah. But yeah, just think of it as a new form of transaction. So what the user will do is that you will send this user operation into this alternative mempool. The second step is there's this new thing called bundler, right? This bundler will receive the user operation from the mempool and bundle it into a transaction called a bundle transaction. So a bundle transaction is a single transaction that contains multiple user operation, right? So yeah, this is the second step. And the third step is that once you have this bundle transaction, the bundler can send the bundle transaction to a contract called entry point contract. So this entry point contract is a global single contract, meaning that only one can exist in one chain, meaning that it can only, let's say only one entry point contract can exist in Ethereum mainnet, right? So yeah, that means that people have to do a lot of auditing on this entry point contract before releasing it to the mainnet, because it's going to be used by everyone in terms of account abstraction, right? So this is the third step. Once you send the bundle transaction into the entry point contract, you would call two different contracts. One is user wallet contract. The second one is paymaster contract, right? So from this diagram, for now, you can see how the decoupling works or the separation of concept works. The user is here and his account is here, right? Or his wallet is here. So it's totally being decoupled, right? They are not merged together, right? So the user wallet contract basically holds the funds, and then the paymaster contract basically you will check whether is it being authorized to pay gas fee for that particular user, right? So as simple as that. And the last step is basically just this. Once everything is being executed, it will be included into a block like a normal transaction, right? So yeah, this is the simplified version of how EIP 4337 works. You have 5 steps, right? You have user sending user operation to the mempool. Bundler will bundle it into a bundle transaction and send it into a entry point contract. Entry point contract will call user wallet contract and paymaster contract, and then this transaction will be included into a block like any other normal transaction, right? So yeah, it looks simple, but I believe it's very hard to implement. Yeah. Okay, let's talk about the major changes and problems faced. So the major changes are, it basically introduces a new form of transaction called user operation. And then you have to also implement something new called bundler, and you also have to implement an alternative mempool. But the advantage here is that it does not require protocol level changes. That means that it doesn't require hard fork, right? I believe, yeah. And the problem faced is firstly the user operation. It will introduce a higher gas fee, right? And if you think about it in terms of the long-term goal of replacing EOAs completely, it still doesn't achieve that because a wallet is built on top of this particular EIP, they still remain as second-class citizen, meaning that EOAs still exist. But the advantage here for this EIP is that it's a good start, right? It's a good start to experiment with account abstraction. Right, so now you have gone through the history. I believe, hopefully, you understand what is account abstraction now in terms of both the high overview and also a high level overview and also the technical details. And let's talk about the current state of adoption. In terms of the implementation for this particular EIP, it's being done by actually few companies like StackUp, Infinitism, and also Nethermind, right? So they are implementing all this, the bundler that I mentioned, and also some of the contracts I mentioned just now. And secondly, there are some L2 that will actually support account abstraction. For example, Snarknet and zkSync. I believe there are many more as well. And thirdly, there are actually quite some account abstraction wallets that are being developed. The first one being ArjunX, which is built on the Snarknet ecosystem. Then there's Soul Wallet and StackUp Wallet as well, and potentially Trust Wallet. Yeah. So this is pretty much the summarized version of the state of adoption. And if you think about it in terms of the future for account abstraction, in the short term, protocol changes won't happen anytime soon. This is, I think, discussed by Vitalik as well. And what he says is that the Ethereum Foundation will focus more on experimenting in the layer 2 protocols because they have lower fees, and it's much faster to experiment with account abstraction in layer 2s like Stucknet. And I believe what he also say is that he wants people to sort of like start to prepare for this shift from EOAs to account abstraction, at least in the short term, by ensuring that the decentralized applications are compatible with smart contract wallets. But that's what he said, but I don't see any practical implementation of this compatibility, at least for my research. But feel free to chip in if you have found any research materials on this. But yeah, in the long term, I believe what they want or what we want is to replace EOAs completely, because smart contracts are much more flexible and it can support many more features, right? And definitely we will require some major protocol changes because EIP 4337 is still not perfect, but it's a good starting point, right? And there will also be some EIPs to reduce gas costs and also to improve nodes incentive and possibly changing some of the some parts of the economy model a little bit. But yeah, it's still in the long term. So yeah, we are reaching the end. So just to summarize, basically what account abstraction is trying to do is to replicate Web2's user experience with Web3's technology, right? As simple as that. It solely focuses on the user experience mainly, right? And in my opinion, Why am I so excited for account abstraction is because I believe account abstraction will be the catalyst for a ChatGPT moment for blockchain. If you want to onboard more users for user adoption, I think account abstraction will be the key catalyst for this ChatGPT moment to onboard, let's say, 100 million user into the entire ecosystem. So yeah, that's it for account abstraction. Hope you guys find it helpful. Yep, that's all for me. How does DK Snug come to play with account abstraction? Well, this is not my expertise. Maybe Chi can talk about this.
Thank you. So ZK Snug has nothing to do with account abstraction. They are two entirely different concepts. Yeah, I think that's the short answer.
Yeah. Maybe you can think of some use case of ZK Snug with account abstraction. But I think currently I don't see any connection as well. Yeah, AA sounds very promising. Yeah, it does sound very promising. But yeah.
Okay, so just that ZK Sync support AA. Yeah, because ZK Sync is basically like a new, you can think of it as a new chain. So as Stucknet. And they're free to change whatever they want. So they support AA natively in the chain. So yeah, that's where the connection comes in.
Yep. So any more questions? If not, I'll pass it back to Kevin. Cool. All right. So yeah, Kevin, let's take over.
Yep. Thanks, Johan. Very good talk on the abstraction. So